Okay, we'll go through the first few questions really quickly, I think. They're quite easy with a GDC. So, first median. So, notice the data is already arranged from the smallest to the biggest. So, the median is just the one in the middle. Where's the middle? Here, right? Yeah, with 5 on the right and 5 on the left. So, the median is in between 4.4 and 4.5. So, you add them up, divided by 2. So, it's 4.45. Interquartile range would be Q3 minus Q1, Q3 being the upper quartile. Upper quartile means you go to the upper half that is separated by the median and then find the median of the upper half. So the middle one is the upper half. This is Q3. Similarly, this is Q1. Then interquartile range would be Q3 minus Q1, which is 3.8. Then outlier. Usually they don't even tell you what's an outlier. I don't know why they are suddenly so nice. So 11.7 should be an outlier that's too big. So we'll use this one. So it's upper quartile plus 1.5 times the interquartile range. So we'll calculate that. 11.7 is bigger than 11.4, therefore it's an outlier. Question 2 is also all calculator. You just type in where's X? Both function e to the power of 2x, and then graph, and then ask for the intersect. So the first one is a negative 0.91656. The second one is 0. The area enclosed is also could be found by the calculator. So integral between lower bound. The lower bound would be the smaller intersection. So negative 0.91656. The upper bound would be the bigger intersection, so 0. The area is 0.239855. So in 365 is 240. So your calculator probably have similar functions. You need to learn to find it out. Next is regression line. Oh, usually they won't tell you this. You're expected to know this. The regression line passed through the mean point. So if the mean of x is 7, to find the mean of y, you just substitute in the mean into the regression line, because the mean points have to be actually on the line. So if you sub in the mean x value, you'll get the mean y value. So 16. Given that, find Q. Oh, it seems to be a simultaneous equation, because now we know the mean of y. But to find the mean of y, we could also just add them all up, divided by 5, and make it 16. If we simplify this, 9 plus 13 plus 21 is 43 in the top, and then multiply the 5 to the other side. And then what? 80 minus 43 is 37. Well, so P plus Q is 37, but we also know Q minus P is 3. So we can add them up. P plus negative P cancel out. Q plus Q is 2Q. So it's a simple simultaneous equation. Once we know Q, we put it back in here, so we know P. But of course, the calculator can also solve it for you if you need that. But you probably shouldn't need that, because otherwise, how would you handle paper 1? Okay, 4 and 5 is getting slightly harder. We're given the formula for decibel. I think this is the actual correct formula. We don't need to, but you don't need to know that. So L here is the loudness, and I here is in intensity. Then we have 2 sound. S1, sound 1, have this as intensity, so this is I, and this as the loudness, so this is L. S2 has an intensity that is twice. Okay, so what's twice of this, right? So it's 2 times that. And the question is, what is... Oh, that's already the question. That's the intensity. The next question is, what's the loudness of S2? So to do that, you substitute the intensity into the formula to get the loudness. And if you think, isn't the loudness just twice of the other sound, then the answer is no, because this is a log. And this was one of the actual reasons log was like invented. I have 2 multiplication. But I guess there's no need to go into this much details. It happens to be roughly 63.01. So you see, even if your intensity is doubled, your loudness only go up by like 3. Okay. The maximum loudness of thunder is 115. Find the corresponding intensity. So this one, you will simply sub in 115 into the formula. So it's 115, 10 log. So if you want, you could just graph this or end solve this or something. But it'll be nice if you want to practice your log. So log base 10 of something is 115. That means 10 to the power of this would equal to that thing. You should know this. In case for paper 1, then you divide the 10 to the power of 12. Then 10 to the power of 11.5 over 10 to the power of 12 is law of indices. You do the top index minus the bottom index, so it's negative 0.5. Next is a kinematics question. Particle moving as a straight line with some velocity. Find the velocity when t is 2. Oh, we're just having t to be 2. I'm guessing graphing this would be helpful. So let's graph it. 1 plus e to the power of negative t, we'll put t as x, minus, minus e to the power of negative sine 2t. Now here is where you should make sure your calculator is in radian, because the question is in radian. Like that. Well, how do I know it's in radian? Whenever the calculus is involved, it's always radian. And we're doing kinematics, that's part of calculus. Final velocity when t is 2, just summing 2. So you can ask the GDC to do that for you. When x is 2, the value is negative 0.996. Then B, find the maximum of the velocity between 0 to 2. So time only go from 0 to 2. So you only look at the graph from 0 to 2. Well, the calculator gave me the maximum. The maximum velocity, meaning the y value, would be 1.18. Find the acceleration when it changes direction. Okay, when does it change direction? Change direction occur when velocity is 0, because that's where the velocity go from being positive to negative. Positive means you're going to the right, negative means you're going to the left. So at the instant that you change direction, your velocity have to be 0. The time is 1.658. To find the acceleration, you basically find the gradient of v. You want to differentiate v and then sub in t. But notice you don't have to actually differentiate by yourself. The calculator can do it for you. For mine, I'll do tangent at that point. So the gradient is negative 2.53. But for your calculator probably can't tell you the equation of the tangent altogether, but only the value of the gradient. Right, so find that function, and then you should be able to input the value of x that you want, then it will tell you the gradient.